put that microphone in. Yeah. Oh. Ah, yes. The electronic textbook, of course. That is exactly what I'm missing there. Electronic textbook. Yes. I would like an electronic textbook. It's there. Textbook here. That. Have to. Here. My brain's telling me I gotta do the. Oh gosh. Alright. Right. Let's do. There we go. Perfect. Okay. Alright. So we'll have the people come in and things. Do the things, everybody. Alright. Hello. Alright. Hello, everybody. Hopefully, you're having. Yeah, that's what I want to say. Wait a second. I'm like, what is this? I have to make a message. Oh, yeah, right. Magic. It happens. Holy smokes. Cannot believe it. Cannot believe it. Alright. A good day today. Man, good. Hey, no, Alex, my dude. Alex, my dude. You never have to apologize. You never have to apologize to me, Alex. You come here on your own volition, and you know, I'm glad that you decided to come to my small humble stream. And I see you subbed to me as well, man. Man, holy cow! I didn't even ask for subs on this channel. I don't even ask for subs, period, because it's I don't know. I don't think I deserve the subs. Just want to be a guy that can help in some way. That's about it. Um, the Mighty Tag sent me here. The Mighty Tag sent a lot of people here yesterday. Like 300 people is absolutely bananas. Never had 300 people in this channel in my life until yesterday. You guys are absolute legends. Absolute legends. I'm watching Shari kind of mess up a little bit on the other stream, on the regular stream there. So Shari's trying his best. So I'm really surprised how many times I don't understand sometimes about Shari. He's like he plays so many games and it's just like this incremental learning process. I can respect the hustle. Just wow. I, it's like takes him more time. I thought he would kind of pick up a little quicker. But that's his learning style, so I respect it. Yeah, but that's okay. It looks like he's having legitimate amount of fun, considering his arm there. You know, he's trying his best. So let's hopefully he gets back up to the full health very soon. Getting that cast off. I'm sure it wasn't fun when he got injured. So right, right. That's so true. What can you do? When you have when you only have half your hands of which to work with until otherwise noted. I'm sure he'll do fine though. Maybe I need to make the camera a bit bigger. Last time it was getting in the way, but maybe try this again. Make my face like, oh my god, it's your face, and like, okay, it's my face. All right, waiting on a few more people here before we get started. Usually, it takes a few people here once time passes to come on into the chat there, and then we'll get started here with today's section. Not a lot to do today. What math are we doing today? Well, stuff that you're gonna definitely like. Um, hey, Dr. Dan, my dude, how we doing today? Math we're going to be doing today is we're going to be converting from the U.S. system to the metric system, and vice versa. So all those conversions, if you ever wanted to know the difference between the metric and the U.S. system, there is that's what we're going to be discussing here today, and how to use a couple of tools and how to measure with them. Good morning. Good morning indeed. How are you? JC. How we doing? I hope we are good this morning. I'm doing very well. Very well. I got wonderful people here in the chat today. I think it's the start of a very good day. So I think we're in line for for something really positive today. I just have that feeling. I don't know about you. I just have that feeling. We're in line for a very positive day. Um, I think it's just one of those really good vibes kind of feelings. It's just how I kind of feel today. I got some loos sitting in the fridge. I got all you guys in the chat. You know, we got some good math material today that spans every continent on the globe. Sophros, my dude, how are you? Um, well, I mean, to be practical here, Alex, um, the of course, most of the UK, all the UK is going to use the metric system in some variety. We use the kind of the imperial system here now. Um, for the most part, majority. Hey, I hope you're doing okay over in Germany over there, my friend. Um, uh, one of the things that's important is this is especially important for trade and whatnot is to know the difference between the metric and the U.S. system. So, if you know how to convert, say, metric prints to U.S. prints and vice versa, since you have to work with two different things, then it's important to know. Shot, how's it going? How's it going, my friend? I hope you're doing very well. I hope you're doing very well, my friend. I hope you're doing very well. Yeah, so maybe the UK, Canada, considering they're Commonwealth countries, I guess so for us this point, then since they're Commonwealth countries, then it wouldn't be surprising that they use both. At this point, it it at this point it's very difficult in some ways. In some ways it's really difficult, and in some ways it's not so hard to convert. It just depends where you want to convert very carefully. In the United States, it would cost quite a sum of money to change a lot of things to the metric system, such as highway signs on roads and things like that, because they are measured to an exactness. So wherever they put a sign, they say it's half a mile away. That actually does reflect typically about half a mile away. All right, so you want to give accurate amounts in there. That's okay. Hopefully, you want to stick around here and let's talk about mathematics. So they actually did try that out a while ago. This is way back when, where they tried to put signs and meters in one part of the U.S. as a trial, and the problem was that it cost quite a bit to do, and they felt that the infrastructure was already there in miles and things like that, where it was just too cost prohibitive. Can you program your speed? I mean, I can program the speedos, man. You mean like the water wear there, the bathing suits. Cars are already here in the U.S. both in miles and kilometers on speedometers. All cars here. most cars here, all cars here are programmed in miles and kilometers per hour. So it's just that we're the major one here on a regular U.S. speedometer. So on a regular kind of just speedometer, it'll have a here I'll just kind of put up a picture here really quick. So this is pretty much how it works. So typically they'll have as you can see here, the outside ring here is going to be in miles per hour, and then the inside ring here is in kilometers per hour. So you do have you do have both actually on the speedometer itself for a majority or all cars here in the United States. No. A lot of times it's because of the fact that most manufacturers here in the United States have to either export cars here over to Canada. So of course it's important to at least have it in miles per hour and kilometers per hour, or send maybe possibly send it to other countries where they can be modified and whatnot. So it's not just uh, it's not just I mean, we use it here in the U.S. quite often, but again, one of those things that's important there. Okay, all right. I think we're ready to go here. Got a lot of important things here. Okay, that's fine. Good beans. I've done this. Yeah, economically it makes perfect sense. Right, exactly. So yeah, it's very important to know that the number that you're actually looking at here when you drive a car in the US or a rental car or whatever is in miles per hour. But then if you really want to get the gauge, you have to look at the inner chart. It's a lot more important. Also, what may be important here, if you ever want to kind of yeah, look this up here. I know this was a thing. I know this is still a thing. Um, so you just got to be a little careful, of course. See if you can get a international driver's license or a driver's permit. This will allow you to drive vehicles across the world. Um, so there are certain ways, of course, you want to find a reputable way to find an international driver's license. All right. So the reason why you may want to is because let's say I want to drive in England, but obviously I'm currently in the US and I'm driving on the right side of the road. Of course, you know what? I'm going to need to learn how to drive a car driving on the left side of the road, and with all the console being on the right side of the car. So it's important to at least get used to both types, and knowing, of course, the rules of the road, in general from an international perspective. And that way, if you do have an international driver's license, that's pretty much accepted most everywhere. Um, you know, fair enough, fair enough. But yeah, it's good to have that. It makes things very flexible. You can rent a car in another country, so you're not like beholden to public transportation or the like. So you can go where you please with a car if you plan to travel. Let's say you plan to tour the United States, in a car or something like that, or you want to drive to a location. Let's say you want to drive to the suburbs. Okay, then you can drive to the suburbs. And you don't have to worry about waiting for public transport. So thanks, Sophros. Appreciate you, buddy. Come on in anytime. Okay. So, if you ever are interested in getting that, in the future, that's very, very important. Not many places accept U.S. driver's licenses because we drive on the right side. So, all right. Anyway, all right, all right. Let's get going. You're right. Okay, let's get started today. Welcome back to Wednesday. Um, End of the week time today. Well, maybe not for this class, uh, but normally it'll be the end of the week time today. So today, yes, as a reminder here, of course, we are going to be having a class here on Friday here at 10 o'clock. I'm not going to forget again, and I'm not going to oversleep again. I know I'm an old man, but I gotta be a better old man. So we're going to definitely do that. All right. So for today, let's talk about what the priority is here for today. So for today, we're going to be doing the last two sections here of chapter 5. That's what's on the docket here for today. All right. Um, I don't look that old, but I'm 41. All right, that's how old I am. I know people look at me like, wait a second, how can you be 41? And be like, yeah, this baby face. Let me tell you. It's lasted me a decade. I don't know how. Yeah, doing good, right? I don't even know how. I don't even know how this face came to be. So it's like, okay. It's like, here's a face that's 41. I'm like, the heck is this? I look at myself in the mirror after I shave. I'm like, man, yeah, this is like another 5 years just knocked off for no reason. All right, go back to old man mood here. I use no moisturizer whatsoever. I swear to goodness, I use zero moisturizer. My skin is super sensitive though, but I use zero moisturizer. All right, so for today, let's talk about what we're doing today. We're um, today we're going to be talking about how to convert from the metric system over to the U.S. system and vice versa. All right, so last time we did talk about both systems here, the metric and the imperial system. Today we're now going to be interchanging between the two here in section 5.4. So that is what we want to focus on here today. So let's go ahead and do that. Alrighty. Okay, now, once again here, one of the things that I'm going to stress here in this particular section is, again, I'm not really going to make you go ahead and memorize, of course, the conversions here. We want to go ahead and use those conversions here appropriately, and then go ahead and apply them in the problems that we want to be looking at. Okay, but the same key is going to hold here. We want to go ahead, let's not forget the key that we talked about here from last class. Again, know, again, what units you would like to convert to. Because again, every problem is going to have a different, different units that you want to go ahead and convert to. So whether that be, whether it be temperature from Fahrenheit to Celsius, Celsius to Fahrenheit, or again, maybe converting from kilograms over to pounds, or whatever the case may be. All right. So first and foremost here, where's that chart? Just like where is that Pokemon? Let's see. It's going to be on page 335. So I'll go to the previous page here. And so there on the top part of page 335, you're going to see a nice little conversion chart there. All right, for say length and area and volume and weight. There's a couple of them that aren't really listed all that well. It's kind of weird that for whatever reason some of them are not listed really at all. So one of them actually that's not listed, even though it's kind of implied, is an approximation for like a pound, for example. So like for example here, 1 pound is like 0.4536 kilograms. Another way to do that conversion here is this, and I'm going to actually put this down here in this sheet, is basically saying 1 kilogram, if you ever want to convert, kilogram to pounds, is equal to approximately 2.2 pounds. So 2.2 pounds, so think about it this way. If you're thinking about how much you weigh, like my fat butt, and how many kilograms I actually am, I actually divide by 2.2, and then I can figure out how many kilograms I am if I need to, say, report my weight in another country or something to that effect. One of the most important ones here, though, is also is listed in this chart here specifically, and this is universally accepted here, and that is 1 inch is exactly 2.54 centimeters. This is an exact. This is exact. All right, so this also implies if you're trying to do stuff in millimeters as well, 1 inch would be equal to 25.4 millimeters. Okay, so these two guys here are the most commonly used conversions here. If we're talking about, say, manufacturing and things like that, these are used very, very often, as most things are put in centimeters and millimeters in terms of dimensioning of some variety. Okay, converting it to meters isn't too hard from there, but you get the general idea. Those two I've seen on many, many tests and whatnot. And if you're doing, saying, a manufacturing test, I've seen that quite often. It's probably The two most kind of important conversions you can ever use. Other conversion. Let's talk about other conversions because there's a couple of them on here that aren't necessarily listed. So we want to go ahead and met that out here to take and all right. So go ahead and put that on. Okay. So the next one here that we're going to put is for temperature. Okay, so temperature is very important. Again, if you travel overseas, most or all temperatures are listed in degrees Celsius. So, of course, you're like, well, how do I equate degrees Celsius and degrees Fahrenheit, for example? Well, we certainly have a way of doing so. All right, so first and foremost, let's go ahead and talk about degrees Celsius here. Uh, so C here for Celsius is going to equal, let's see, 5/9 times the quantity, degrees Fahrenheit, minus 32. So again, as we know, 32 degrees Fahrenheit is equal to the freezing point of water, which was equal to 0 degrees Celsius. Okay, so hence that is the conversion there from degrees Fahrenheit to degrees Celsius. And if we want to actually go backwards, if we want to figure out what degrees Fahrenheit is, so let's say you come from overseas, you come here and you're like, well, how many degrees Celsius is that going to be? Well, there's certainly a way to go ahead and find that. So degrees Fahrenheit here is going to equal 9/5 times degrees Celsius, or again in Fahrenheit, I guess I should say. I got it backwards anyway. Plus 32. So if you want to find out how many degrees Fahrenheit from degrees Celsius or degrees Celsius from degrees Fahrenheit, you can go ahead and do so. They're really not too difficult of conversions there. But nonetheless, for temperature's sake, of course, we want to state those. All right. So very good for traveling. Very good for if very good for like if your mental calculations are in one one system or another system. Okay, it just depends at the end of the day which way you decide to go. Okay, good stuff. Now, having said that, of course, let's go ahead and take a look at some questions, right? And let's see what we could work with. Yeah, let's do it. I'm going to leave these up here just in case if we uh, have that. Back that. All right. Which one I want specifically? Ah, that one's actually a really good one. All right. That's one of my favorite problems here. All right. Okay, so we're going to do this one here, which is number 7. All right, so this is a really good question here because I've actually encountered this doing this in my head at least once. Number 7. Which is performing more efficiently? A car getting 12 kilometers per liter of gas or one getting 25 miles per gallon of gas? Okay, now I've seen commercials there when I was living in Japan that they would promote cars getting X amount of kilometers per liter. Okay, or again here, of course, we talk about miles per gallon. So you're saying, well, which one is more efficient with your gas? All right, so let's take a look at it mathematically, and let's see exactly how we can figure this out. Okay, let's go ahead and bring up here Angel. Now, Now we can go one of two directions here. So let's take a look at it. We have 12 kilometers per liter, or one. We have 12 kilometers per liter, or we can take a look at the other side of things, which is going to be, let's see here, 25 miles per gallon. So we're just 25 miles for 1 gallon of gas. Okay. Now, like I said, we can go one direction or the other direction. We can either convert from kilometers per liter into miles per gallon, or we can convert miles per gallon into kilometers per liter. As long as we put it in the same context, then it should be easier for us, and then it should be simple for us to just compare the two, see which one's bigger, and we call it a day. Okay, so I'm going to leave it up to you guys here. Why don't you guys tell me, which way do you want to convert? Do you want to convert from kilometers per liter to miles per gallon? Or do you want to convert it the other way, miles per gallon to kilometers per liter? Which way would you want to go? I'll leave it up to you. Well, miles per gallon to kilometers per liter? Okay, well, let's take a look at that then. Perfect. Let's do it. Okay, so let's start off with our first initial value. Okay, so let's first start off with 25 miles per gallon. Okay, so you notice I wrote that on purpose. And again, let's not forget what we want here, right? We want kilometers per liter. Okay, we want kilometers per liter here. So we want kilometers on the top, and we want liters here on the bottom. So we're going to take it one piece at a time here. So first and foremost here, let's look at miles. We want to convert miles into kilometers. Okay, that's what we want to do. So let's take a look back at our chart here. We're going to reference the chart here once again. That's on the previous page here. I'll bring this back up. All right. So based on what you see here, which conversion are we going to be using here in this case? Let me, excuse me. What should I multiply by here? Which one should I use? I'm trying to convert miles into kilometers. What do you guys think? It's there on the list, so okay, very good. That's right. So I want you to take a look at this one here. Let's take a look at this carefully, okay? So we have 1 mile is approximately equal to 1.6093 kilometers. Okay. So okay, that's right. So what we want to have happen here is, oh no, that's okay. That's okay. No problem. So what we want to look here in this case is, do we want to put kilometer? Do we want to put 1 mile here is 1.6093 kilometers? Do we want to put that on the? Do we want to put miles on the top or the bottom? Do we want to put miles here on the top or the bottom? Yeah, on the bottom, right? That's really important here. Because we want to take away the guesswork, right? So we're just eliminating miles here, right? Because remember, right, we want to take away miles and we want to leave kilometers here on the top. Bottom kilometers is what we want. And just be a little careful there, Alex. What we want is kilometers here on the top, because what we want in the end is kilometers to be on the top here at the end of our answer. So to take away the guessing here, That's why I asked the question here, where do we want our units? If we can cancel out the miles units and leave kilometers on top, that's exactly what we want to have happen. So that way we don't have to guess where the units have to go. We can see what we want to eliminate and then leave what we want. As long as you know what your goal is at the end of the day, you don't have to guess about where these units necessarily need to go. And then you can follow exactly the steps that you have from there. So that's why I kind of set it that way. So it's like, okay, you can physically see what you need to use, like for what you want to do, if that makes sense. Okay, well, let's try the next part here. Now we have it in kilometers, but let's not forget what we want here. We want kilometers per liter, right? If we're going to make a proper comparison here, we want kilometers per liter. So we want liters on the bottom here. And let's take a good look at our chart here. So I'm going to bring over the chart. What conversion can we use now if we want liters here? What conversion should we use here? Okay, 3.785 liters. Okay, very good. So 1 gallon here is equivalent to 3.785 liters. Perfect. All right, so let's go ahead and put that down. So I'll put in all right, so we're going to have liters here. Are we going to have gallons on the top or gallons on the bottom? Top. Okay, good. Right? Because that'll allow us to eliminate these gallons. And then we'll have 3.785 here. Bottom. All right, perfect. We want Brenton, we want gallons here to be on the top. Remember, we want to cancel out the gallons units here. So we need 1 gallon unit on the top and 1 gallon unit on the bottom. Okay. So remember, my goal, the reason why I asked that question is just because that just makes us double extra sure, hey, where are we canceling out our units? Okay, I want to have this unit on the top, this unit on the bottom, so I can cancel it out and leave the remaining unit to be where it needs to be. So be sure to kind of ask yourself that question every time down we do these conversions here. Now, let's go ahead and, of course, from here on out is calculator time. So we're going to take 25 times 1.0693. That's going to be kilometers here up top, of course. And then we'll divide that by straight up 3.785. All right, so we're going to have, of course, again, straight up calculator time. There's no other way around it outside of that. So all right. And can anybody tell me what they got for their answer? Just want to make sure we got that right. Anybody got a final answer for me? Okay, good. 10.629. All right, that sounds fine to me. All right, perfect. Absolutely, 100%. Brenton, that's correct too. So we'll go 10.629. kilometers per liter. So in this case here, if we were to compare the two, a 25 mile per hour, 25 mile per gallon car is not as efficient as a 12 kilometer per liter car. So your winner here is an advertisement that would say a car getting 12 kilometers per liter. That is your winner. We compared the two, and this is definitely the case. Okay, so that is how we can compare, let's say, fuel efficiency in vehicles, just using nice little conversions there. Okay, any questions about that? No? Okay, cool. All right, let's go ahead and try another problem. Okay. Okay. All right, let's want to look at another one here. Okay, yes, that one. That one's actually very important. So let's go ahead and take a look at this one here. We've seen a couple of these, so I want to do. There's like here, sure here. Okay, yep, that one. And then there's that one. Okay, perfect. All right, so let's do this next one here, which is number 14. Okay, so number 14. Fried crickets is served as an appetizer sell for 5,400 Cambodian riels per kilogram. If 4,060 riels are equal to $1, how much will 5 pounds of crickets cost in US dollars? Fried crickets. There you go. Fried crickets. I don't know if any of you eaten you fried crickets. No. You don't want to eat fried crickets? Oh, what about chocolate covered grasshoppers? What about something like that? Chocolate covered grasshoppers would be pretty good. No, no, they're not bad. They were pretty good. Pretty crunchy. Got that nice sweet crunch to it. I think the thing that I've eaten the worst thing I've ever eaten, which should have been fried, would have been a silkworm. I ate a raw silkworm once. And I was like, oh, that thing tastes so chalky. But if you fry it, they say it tastes really good. So good for protein. Yeah. I just ate breakfast things. Well, how about squid? Squid is outstanding. Squids. No, nope, nope. How about calamari? Calamari pretty good. Yeah. Got a weird taste. Well, variety is a spice of life. You gotta try a lot of different things. Variety is totally a spice of life. Octopus legs, heck yes. Octopus is really good. The only issue that I have with octopus is that it's just really heavy, but it's actually really good. So it's just like I can eat like a few pieces and I'm like, okay, two few pieces there, and I'm like, all right, that's enough. But octopus is pretty good. If you've eaten calamari, calamari is just basically just squid. Just fried squid. Taste outstanding. Squid with mayonnaise. Mmm. Outstanding. All right. Anyway, let's go ahead and figure out how to let's go ahead and figure out how we look at this here. All right. So, fried crickets served as an appetizer sell for 5,400 Cambodian riels. 4,060 riels are equal to $1. How much will 5 pounds of crickets cost in US dollars? All right. So in this case here, what we want to do is notice that the price here is per kilogram, not per pound, but per kilogram here. So we need to figure out how many kilograms 5 pounds is going to be here first. All right, so let's do that first. So let's go ahead and look at the chart here. We're buying 5 pounds of crickets. 5 pounds of crickets, all right? And we want to convert that over to kilograms. So what is the conversion there? What is the conversion there from pounds to kilograms according to our chart there in the book? Let's go back here for a second. And we're just going to reference the chart here. Previous page, sorry. It's a lot of back and forth for this section, so. Okay, very good. So 1 pound is equal to 0.4536 kilograms. Perfect. All right, so let's go ahead and write that down, at least for our problem here. Okay, agree with you there. So let's answer the question once again, okay? Does the 1 pound part in this conversion here, should that go on the top or should that go on the bottom here? Okay, that's correct. The answer is the bottom. That's right. That way, we're able to cancel out our pounds units. Perfect. Nice. And we'll put the other one here by default here on the top. Nice. So let's go ahead and multiply this. Can anybody give me an answer here? 5 times, just use your calculator, of course. 5 times 0.4536. All right, 2.268. Okay. Let me make sure of one thing. I actually got to make sure. Okay, that's fine. Okay, 2.268. All right, that's fine. Yeah, I know. You just accidentally missed the 6 there. I kind of figured that was the case, Brendan. No problem, buddy. No problem. Okay. All right. So 2.268 kilograms is going to be our friend here. Now, in this case, let's go back to our question here because we do need to reference the original question. Let's go back to our question here. A couple pages here. Okay. So, in this instance here, let's look at this one here. So, it sells here at this local market for 5,400 Cambodian riels per kilogram. Okay, so that's the selling price here at this local market. All right, so okay, So if we're going to do that here, let's go ahead and multiply this new amount. Let's multiply that by our kilograms, which we're going to put here on the bottom for this one. And we'll have 5,400 riels on top. This will put it into the local Cambodian currency here. And then finally, what we're going to have here is we're now going to go ahead and convert this into we're going to convert this into dollars, because we do have one more conversion here. So let's go back one more time, and that says 4,060 riels are equal to a US dollar. So so where should riels go? Should riels go on the top or the bottom here? All right, the bottom. Right, so we're going to have 4,060 riels on the bottom. Perfect. So we'll have riels here, and then we'll have a dollar here up top. Now, as you can see here clearly, now you know what to enter into the calculator here. So we're going to have 2.268 times 5,400. And then we're going to divide that by 4060. And we're going to round to 2 decimal places since we're dealing with just money here. So let's go ahead and do that right now. All right, and does anybody have an answer for me here? All right, good. So to buy this bag, it'll be $3.02. That is correct. All right. A pretty good price for a bag of crickets, I'll say that. All right. Any questions about that? Nice job, everybody. So far, so bueno. Alrighty. Let's look at the next one here. All right. So we have let's look at the next one here. I want to look at. All right. So last one here for them, this section anyway. We're going to look at number 19. So number 19 says the normal cruising speed of an Airbus A380 is about 250 meters per second. What is this speed in miles per hour? Okay, so our conversion here is very clear. We're given the speed right now in meters per second, but we have to convert to miles per hour. All right, seems fair. So let's go ahead and see what we get. All right, and what we want here is, when again, we want miles per hour here, just as normal. Now, I think that the easiest part here in this problem is just we want hours on the bottom, for example. And in that case, it's actually not hard to figure out what we need to do here. We're going to convert seconds into hours here. first and foremost, and then we'll do the tough part here with the meters, turning that into miles. So let's just use regular time here. I think most of you guys know how that works. Again, we'll put 60 seconds on the top here, put 1 minute here on the bottom, and then we'll multiply that by 60 minutes on the top, and 1 hour here on the bottom. Again, seconds cancels out, minutes on the top and bottom here, those will cancel out. So as you can see here, we're left with hours here on the bottom. That's the easy part there about just using time. Really doesn't require too much effort for that part. So the part I want to focus on, though, is I want to focus on the meters. Okay, I want to focus on meters here. All right, and that's going to be kind of the key here, is we want to convert meters here into miles. Okay, so let's see how we can do that. Let's go back to our conversion. Okay. All right. So which conversion can we use here in this case? Which conversion is the closest to miles and meters that we can use here in this case? So that's fine. That's fine. What conversion is the closest? Okay, so this is going to be a case where we're not going to necessarily see a direct conversion. So if you don't see a direct conversion here on the chart, which one is the closest? You said you see kilometers but not meters. But maybe that is the closest to relate miles to meters, right? So which one would you use there then? Okay, that's right. So we're going to use that conversion here. 1 mile is equal to 1.6093 kilometers. Okay, now we're going to discuss why that is here. All right, so I'm going to write that down, of course. So 1 mile here equals 1.6093 kilometers. Now we don't quite have the pieces put here in place to use that conversion just yet, but we will here in just a moment. Now, you're like saying, well, we start with meters, so where does this kind of come into play? Well, we're going to use this as our intermediary point. If we can convert meters into kilometers, then we can go ahead and use this conversion. So that's really the big key of this problem here. Key here is to convert meters into kilometers and then into miles. So we may have to do a secondary conversion before we do the actual main conversion. So here's the question. Let's think about meters and kilometers. Well, how many meters are in a kilometer? How many meters are in a kilometer? So I'll type that down. How many meters are in a kilometer? Okay, that's right, 1,000. That's correct. So we have 1,000 meters, and this is from our basic metric system, is equivalent to 1 kilometer. So that's what we're going to do here. We're going to basically have 1,000 meters here on the bottom, and we'll put 1 kilometer up top. Again, that will cancel out our units for meters, okay, and then leave kilometers up top. And now we can go ahead and use our conversion here of 1 mile is equal to 1.6093 kilometers. So now we'll put 1.6093 kilometers on the bottom here. I'm going to cancel that. Put 1 mile here up top. So let's take a look at what we have here. So we have 250 times 60 times 60. Put those in parentheses. And remember, just like last class, we need to put the bottom here in parentheses as well. 1,000 times 1.6093. Okay, and we're going to get an answer for this here. So all right, and does anybody have a final answer for me here? Yeah, Brent, that's way too small. I think I know what. I'm not sure what you did there off the top of my head. Try that again, Brendan. You should get exactly what Jasmine got there, though. Should get 559. 0.249. Yeah, 249. Remember, it's just like what we practiced last time, Brenton. Using those parentheses in the right places. Okay? All right, so 559.249 miles per hour is going to be our answer. All right. Any questions about that? No? All right, perfect. All right, you got it, Brenton. Perfect. So that's what you see on the calculator there, then you did it correct. Ah, you forgot the 2, that's why. Okay. Yeah, all right. That would make sense. You accidentally hit 50 instead of 250. All right, that makes sense. All right. Okay. All right, let's take a good look here at the next section. Okay. So the next section here talks about something very important here if you're in manufacturing. All right, so I'm going to bring that up here. So this is the last section here of Chapter 5. Section 5.5 is So these are direct measurements. So this is basically applicable. This is basically applicable here. What Scooty asks, what grade of year maths is this? This is actually technical mathematics. But this doesn't really have a grade level here. We cover a lot of different surface level topics from basic arithmetic all the way up through trigonometry. Okay, so this is made for people who are going into the trades of some variety, whether that be nursing or welding or HVAC or the like. So this class here is a little bit more of saying, hey, what are the practical applications of what you're going to be doing on a day-to-day basis at your job sort of class, which is why this is probably my favorite class to teach. But yeah, to answer your question, Scooty, that's what this class is about. Okay, so the next thing I want to talk about here is we're going to be taking a look at two tools that are used very frequently, at least within a manufacturing shop, all right, in order to do some proper measurements. The first one here is talking about a micrometer. All right, now if you've never seen a micrometer, let's take a look at one here. Um, so a micrometer looks like this, okay? Here's what a micrometer looks like, okay? Very, very nice tool, okay? This is used to measure things that are, again, this can measure length, width, or depth of a particular part or piece, okay? These can come in millimeters or inches or the like, all right? We're going to be talking about micrometers here and how to measure things on a micrometer specifically. So we're going to go through the steps here on how to measure on, say, a device like this. Oh, you're using that yesterday for your, yeah, yeah, you definitely one of those things that is really super handy. And everything that you do here is entirely based in mathematics to figure out what that actual measurement is. So yeah, Jasmine, this is definitely going to be one of those things that definitely will be very, very useful if you're using that for your regular daily basis sort of deal. All right. Now there is going to be two types of micrometers here actually, and we're going to explore both of them here. There's only one difference between the two, and we'll just point out what that difference is specifically. So there's kind of like this regular micrometer. Okay, basically it kind of looks something akin to this. Okay, here's this micrometer. It has a thimble. It has a sleeve. Okay, it's very straightforward. Okay, not too much trouble here. All right, very simple. So we have a regular micrometer and then there's a Vernier micrometer. This is basically a micrometer with a Vernier scale. Now, what exactly does a micrometer with a Vernier scale look like? Well, if you take a look at this picture here, there's not really anything at the sleeve here. All you see is the numbers here, 0, 1, and 2, and some numbers here on the side. This micrometer, on the other hand, this picture here, if you see these lines up above the actual sleeve here, these lines here are what we call the Vernier scale. So we're going to look at some pictures, of course, from the book here, and we'll see exactly, how we can read with the Vernier scale or without the Vernier scale. It just depends on what kind of micrometer that you actually grab. The Vernier scale just offers a little bit more precision and adds an extra decimal place to the measurement itself. So it's one of those things that certainly, if you want to be even more refined with your measurement, that's what the Vernier scale will allow you to do. All right. Again, not every micrometer has this, but maybe it's not a necessary need for what you need to use it for. It is what it is. Okay. In any case, let's talk about how we can go ahead and put it together. All right. Okay. So I'm going to need to bring up the book here. Oh, was it here? Oh, I did. Oops. Hmm. Tell me I exited out of there. That'd be sad if I did. I did. Oh, I did. Darn it. Darn it all. All right. No. Yes. Oh, there we go. Never mind. I was like looking at the wrong page. All right. Okay. Nice. Well, I'm really happy to hear that, Jasmine. Jasmine, this is definitely gonna be very, very helpful here. All right. Now, there's also digital micrometers, and digital micrometers are okay, but many micrometers you do it by hand. So yeah, there's also digital scales, but digital scales are kind of sometimes can be a little wonky. So you want to be, you can trust yourself. You can actually see how things work. All right. In any case, this is one of those sections where I wish we could meet in person because I would show you how to do it by hand. With actual micrometers and actual things to measure out. But unfortunately, we just got these pictures here, and that's what we're kind of work with. But let's go ahead and talk about the two main portions here of the micrometer that we certainly want to look at here. Number one, we're going to looking at this picture here carefully. I'm going to be referencing these quite often, so that's why I'm just showing off this picture here. Is here we have the thimble. So this side here is what we call the thimble. And this side here is what's called the sleeve, okay? They call it a barrel or sleeve. I call it the sleeve. That's just the most common term that we use here. So we have the barrel here, which is the outside, which is what you turn here. Let me see if I can find mine here. If I have it in my thing. I could have sworn I had one. Let's see if I can find it. There it is. All right, cool. I actually have one here. Now that I remembered where I put it here. Here we are. It is fun, definitely fun. So here's my micrometer right here. Um, I have one here in my house specifically for this course. So I was nicely gifted this micrometer here. So I definitely if you want to do measurements and stuff, this is super super cool. So as you can see here, what I'm rotating here on screen, this here is going to be our thimble, and this here is going to be our sleeve. This is a good this micrometer here. I know you can't see it here, but this is a Vernier. Vernier's has a Vernier scale on it, hence why the extra decimal point here. So that's so we're going to be using again our thimble and our sleeve here. So we're going to look at both of those here and look at it from a mathematical perspective, and we'll also include the Vernier scale as a possible added extra step, just depending on what micrometer that you work at. Now, of course, in order for you to use this micrometer here appropriately, you'll need to take whatever part that you have. Let me try and find something that's take the I got. Here we go. Let me use this. All right. I got this old flash drive here. All right. So let's say I'm taking the measurement of this flash drive. Okay. And I'm just trying to find out, with this metal housing here, how thick it is. So let me go ahead and just undo this here. All right. So I'm going to put the, this is going to be a little awkward for me, but I'll make do. All right. So I'm going to put this in front of the camera here. So here's here's what it looks like, and I'm gonna keep turning this using this using this ratchet stop here. You always want to use the ratchet stop. And you want to keep turning it until it's flush with, in this case, the piece or the flash drive here, until it clicks. You don't want to go too tight here, so you never want to use the thimble here. You actually want to use the ratchet stop here till it clicks, and then that's going to be where your measurement's going to start here. So, see if I can. Oh yeah, it's metal housing. I forgot. It's probably easier for me. All right, so I'm going to stop it right there. On a regular part here, in reality, this is gonna click and you're gonna stop. Okay. So now what I'm going to do here is since I've stopped here, again, I just kind of revolve stuff around. We're going to measure this out and see exactly how thick this flash drive is going to be, or whatever part it's going to be. Okay. Just by looking at the sleeve and the thimble here, and using a little bit of math. Okay. So it won't be too bad. Let's give it a go. Okay. Alrighty. Perfect. All right. So let's go to a picture here, and we're just going to go through each step here carefully. So the steps here are on the screen, but I'm just going to point it out here. Of course, these are idealized versions here, but it may not be as so idealized as what it is in real life, obviously. But we're going to take a look here specifically, and we'll see how it works. All right. So step one is to basically read the largest visible numeral on the sleeve. So let's go ahead and put that out here. So step one. Uh, so in this case here, the largest visible number here on the number, not being smart today, on the sleeve, and then we're going to multiply it by 0.100. Okay, or as probably you guys know, if you've used this before extensively, like JC has, then certainly you could say 100 thou. Okay, so often see here the word 100 thou, and then that's in reference to using a micrometer there. So fairly common for people to use it like that. So in this case here, as you can see, 4 is the last number you can see here on this picture. Hence why they take 4 times 100 thou, which is 400 thou, or 0.400. Okay. Step 2 here is to basically read how many additional lines are next to the visible number, and multiply that amount by 25 thou, or 0.025. Okay, so what does this refer to here in this example? This basically refers to, let's see, you can see here in the picture, we have 1, 2, 3 lines that we can see here, and this is going to reference to again 1, 2, 3. So that's why this here is 3, and we multiply that by 25 thou. Okay, so that's why we have 25 thou here, and we multiply that by, in this case, 3, and in this case you get 75 thou. All right. Okay. Now, The next one here is reading off the thimble. So we've read off the sleeve here in the first two steps, but now we read off the thimble. Now, it's not always going to be this nice, okay? What's the difference between negligence and ignorance? Oh, that's not too hard. Negligence is basically just either A, forgetting, or knowingly or unknowingly uh, not partaking in an action or responsibility you're a part of. Ignorance means that you actively don't know the knowledge behind an action, or again, you actively decide not to do something. So, or take an action, I guess. Yeah, pretty much. Random questions get random answers. But if you ask, then that's what you get. All right, let's go to step 3 here. So we want to read the thimble here. All right. Now it's not always going to be exactly in line here with the. It's not always going to be exactly in line with what you see here. So maybe in this case it reads 13, but you could be say between 13 and 14. So read the thimble. Read the thimble. And use the number that is that lines up with that most closely lines up with um, the I want to say the yeah I guess I'll have to say it that way as the book says the horizontal line on the sleeve. Yeah, what do you do? Yeah, that's a very it's basically that's why I kind of put here. You're gonna use the number that most closely lines up. So you either gonna it's basically kind of like looking at it from that kind of perspective. There is like what I was told a long time ago is like most closely lines up. So it's kind of like a visual thing. You have to kind of make that determination on your own. So if it's between numbers there, you got to look at where that line is. You got to look at where it is between those two numbers, and then either decide to round up or round down. Typically, people try to round up most of the time. So um, it just really depends. Because if it's just like a hair above that line, then you're like, oh, I'm not going to round up because I'm adding too much. But if it's like, let's say it's like 40% over, then maybe you want to round up because maybe you want to overcompensate instead of undercompensate. So it really depends. So to say, uh, actually, I should ask JC. JC, what do you do in that case? What's your standard for that, if I may ask? Is your standard to basically round up most of the time? So the question is that if you're between, let's say you're between say 13 and 14 on the thimble, at your work, do you tend to round up most of the time, or do you round down when you're checking stuff on your micrometer? What's uh what's the standard there that you tend to use at the shop? I guess I just want to hear from a practical point of view there. So. Oh, that was Discord. It's between 13 and 14. We look at the other numbers from the right side of the micro. Okay. So basically, you take the Vernier scale after that, and then you basically round from there, if you need to. Here, let's say, let me get it here. Second. Let's say it looked like, this. Okay. Let's try and put it up on screen here as best as I can. So let's say it kind of looked like, I know it's not the best here, but I'm pretty bad at this. Let's take a look at the picture here. Sorry, my B. Take a look at the picture here. If this was between, say, 13 and 14, like right here, on the thimble, like right here, what would you call that? I guess is the question. Would you call that 13 or would you call that 14 if it was right here, right where my cursor is? You'd still call that 13. You'd round down. Okay. Okay. That's fair. So let's kind of go with that then. If that's I'd rather use the standard there because every shop is different, but I'd rather use the standard there if it's not. So yeah, you don't want to overshoot. Okay. Okay. So let's go with that premise there. Um I've been told a little differently, but you know what? I like the more practical sense. I like the more practical point of view. So I'm going to go with JC's point of view here from here on out. All right. Let's go with this fact that we want to round down as round down. So sometimes I just, sometimes I need perspective from somebody who's doing the job there. So okay, there we go. Let me go ahead and change that step 3 there. All right. We will multiply though by 1 thou. Okay, just like so. All right, so that's step 3 there. We'll take a look at some examples here, but just to kind of show off there. Okay, and then we have here step 4. Okay, so step 4, this is if a Vernier scale is available. So if the vernier scale is available on the micrometer here, what we do is on the vernier scale here, we want to go ahead and line it up. Once it's stopped, we take a look at the lines here. There's on the vernier scale, there's say 10. There's 10 different lines here on a vernier scale. 10 of these different lines, and I'll show this off here on this page. There's a page here with the vernier scale. So just want to kind of show that off here. This on page. Okay, anytime now. All right. So here's a generic, just a very top-down point of view here. Here's the sleeve here. Again, here's the horizontal line right here, and up above you see from 0 to 10, or again from again 1 to 10, or you'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, for example. And so these short lines here are going to be your vernier scale. And so what you want to do here specifically is the vernier scale works a little differently than the other scales. And so what do you want to do on the vernier scale here? You want to find the line on the vernier scale that best lines up with the lines on the thimble. So you want to find the one that best lines up with. Not every line is going to line up perfectly. So if I took a look at this one here, let me show you. Oh yeah, and multiply by 0.0001. Okay, so if you take a look here, notice this line doesn't line up here. This line doesn't really line up here. I don't care what these numbers on the right-hand side are, but I really care about, what lines up with which. So which line lines up the best? Okay, not this one, not this one, not this one. Okay, but I can see that this one here would be our winner. This would be 8. Okay, so this would be 8, and then I would add up 8 there as our last decimal point. Because again, 8's the one that lines up the best here, based on the lines here on our thimble. Right, exactly. So I just wanted to show off here and say, hey, well, what do you do in a vernier scale case? Okay, well, there you go. That's what the vernier scale case is going to look like here. Okay, that kind of last decimal point here for that extra precision. Okay, let's take a look at some examples, though. I think it's always a good idea to use some examples, of course, on a practical level. And let's start putting this together. So let's do it. Yeah, good job. All right. Where is it? Here we go. Ooh, what? Oh, okay. I was looking at the wrong page. Okay, no wonder why. All right. All right, so let's read these following micrometers. The exercises I did yesterday were horizontal. What are the numbers on the bottom right? Numbers on the bottom right? Are you talking about the sleeve or the thimble there? Number 7? Oh, these, right? You're talking this one right here on the screen? Or are we talking about example 7 from that page? Okay, so example 7 on this page, this is the vernier. Oh, this page, okay. Fair enough. Yeah, so this is the vernier scale here. This is the vernier micrometer. So we can read this here. Let's go ahead and do that together then. I don't mind doing that. That's just fine by me. let's look at this then. All right, so if this is the, yeah, so let's look at number 7 here, and let's reason it out here, okay? So we're going to start putting this together here one piece at a time using our steps from before. Let's do it. That's a fair question. I only need this. All right. So first things first here. The first number, we're going to look at the sleeve here. Okay, so the sleeve here says we see a 4. So we're going to take that 4 and we're going to multiply that by 100 thou. Okay, so that's where we see the 4 here. Okay. Next, we want to see how many of these lines that we see here. Now, we don't see any of these extra lines here. So in this case here, we're going to put a 0. But the second steps here says to go ahead and multiply by, say, 25 thou if there was a line here. Now, we also want to look at the side here, which is going to be the thimble. What's the line that best matches up? Well, here we see 5, and then here we see 6 and 7. So this, where it lines up here with this horizontal line on the micrometer, it looks like it's a touch above 6. And since we did talk about this here, we're going to round down to 6 here. So we're going to take our 6 and we're going to multiply that by 1 thou. Okay, so we've done the first 3 steps here so far. Now let's look at our Vernier scale. We want to find out which one of these lines here best lines up with the thimble here on the right. So it's not this first line, not the second, not the third, not this, not this. Let's see, 4 here, nope. 5, definitely not. 6, no. 7, maybe. But it looks like 8. 8 is the one that looks like, once again, is going to be your winner. So 8 here times 0.0001, all right, what we're going to get here. And now all we want to do is add up all these together here, and we're going to get our accurate measurement that we want here at the end of the day. Yeah, this one is a more precise micrometer here, again, because of the fact that we have this extra scale here. You probably used this micrometer here like in number 1 without that scale actually being on there. That's probably the micrometer you used yesterday. So you don't need, if you're using that, it's just basically taking away this last step here. So with your micrometer that you used yesterday, Jasmine, this last step here of 8 times 0.001, that doesn't exist. Okay, it's just these 3 steps that you did yesterday. So you just have one less step to really remember at the end of the day. Why? Why did I do that? Why did I do? Okay, and so we just add these values together here, and so what we're going to get is we have 400 thou. We get so here we get 4. Let's see, here we get 8, and we get 6, 0. So, oops, I put too many there. 4068. I accidentally made that much uglier than what it should look like on here. 3. I don't know why I wrote those so far away, but that's what happened. All right. Okay, so 4068 again goes out to 4 decimal places. So, okay. On a regular micrometer that you use there, Jasmine, it'll go out to 3 decimal places. Let's take a look at another one, though. I think maybe another one certainly is in order. I'm gonna go ahead and erase this and look at one that you used yesterday there, Jasmine. So let's look at number 6 here. Okay, so let's look at number 6, right? And we're gonna see exactly how this mets out. Okay, so the first thing that we see here, we see 4 here once again. So we're going to take 4 here, multiply that by 100 thou. Okay. Now, I remember that there was a thing here. Oh. I guess we'll run with that, I suppose. I need to make one thing. I just need to check one thing here. I remember this section here was a little tricky for one reason. So let's check that real fast. Okay. Okay. All right. That's fine. All right. Sometimes it can be a tad bit tricky here. Answer 441. Let's go ahead and find out. All right, so here we have 1 times 0.025, okay, 25 thou. And then we have a 16 here times 0.001, so 1 thou. So this is 400 thou. This is 25 thou. And this is 16 thou. Putting it together, I would agree. 441. Spot on. Nice. Absolutely. I wanted to make sure about one thing here. The book was particular about one thing, but I don't think it was for these problems. So, okay. Just look carefully at the picture, though. Sometimes these lines here do appear like, I will say this, just look at the picture carefully here. Like number 3, you see this line jutting out here from the extreme right. So this is actually an extra line here that sometimes you do see or sometimes you don't see in the picture. So be very careful about that. Okay, good. Nice. Nice job. Any questions about that? I hope that made sense. Takes a little practice and getting used to, but once you have the steps down, it's really not too bad. Okay. All right. Also in this section here, and there'll be some parts here that I'm gonna kind of leave up to you because there's a lot of different direct measurements like rulers and stuff. Most of that stuff I'm gonna leave up to you to kind of read off there. Um, this is not something that is too difficult. Some of the other ones that are in here are basically things that you probably are not going to use on a practical level. Like, how often are you going to go ahead and read an electric meter? I mean, honestly, electric meters, they're old school electric meters, but water meters or things like that. So uh, you're not going to read those very often. And most electric meters these days are digital as opposed to being the old-fashioned ones. So those aren't going to be like super crazy. Protractors are barely used most of the time now. You used maybe comparators or something like that, optical comparators. Um, uh, and then there's also calipers here. Calipers are used again quite often here. Yeah, we could do another example of the vernier here in just a second. Let's see, did I put the caliper? I could have sworn I had one. Put my calipers here. I know I had some calipers, brother. There they are. There they are. I had them. All right. So here is here's an example here of some calipers. I was nicely gifted these calipers a while ago. I haven't used them too much here, but these are this is a this, as you can see right here, is digital calipers. Okay, so again, it has a nice digital scale. You can zero it out, you can turn it off, you can turn it on. Has a battery that comes with it too. All right. Again, calipers again much very easy to use. Again, the plain standard calipers has the dial on it. If you've ever seen plain standard calipers without the digital scale, it has a dial on it that you can use for measurements there. It works very similar to that of micrometers. I think calipers are a little bit easier for depth. So as you can see here at the end of the calipers, you can use it for depth of a particular object. There's a separate one for micrometers there that you have to use, but calipers comes built in. And it's not hard to use. This one again has inches and millimeters and whatnot. And again, for digital ones, digital ones will be just as good as as the regular ones. So these are super duper handy. Okay, so like the calipers there, if you need to use them for some easy to do measurements, some simple measurements, not as precise as the micrometers, because of how you actually measure stuff out. So with micrometers, they're more reliable in terms of measurements because you actually measure them in a line as opposed to measure them on a on another surface. So like with calipers here, you're measuring them between two things like this, but not necessarily in a line, unlike micrometers, which are direct in a line like this. So not off to the side. So there is a bit of a difference there. Second, take it out of this plastic housing. Here. Yep, got it. All right. In any case, I'm going to leave that to you. All right, let's try another Vernier one, as Jasmine has requested. So let's try number 10. Let's try number 10. All right. Number 10. Okay. So let's go through number 10 here carefully. So let's do the same thing as we've done before. Okay. First of all, we see 7 here on this scale. So let's go with that. We do 7 times 100th thou. All right. Here we see 3, 1, 2, 3 of these guys here. So we're going to do 3 times 25 thou. All right. We take a look at our thimble here. Our thimble here is going to be, let's see, a touch above 4. We're going to use 4 here. What did I put for my thing here? Yeah, round down. Okay. I did put that. So 4 times 0.001. And you said 6. Okay, so let's take a look at 6 here. On our Vernier scale, yes, okay, 6 is our winner there. Absolutely, 100%. That'll be our last decimal place there. Let's put it all together, shall we? All right, so here we get 700 thou. Here we get 75 thou. Here we get 4 thou. And here we get the 6 here at the end. So 6 here perfectly lines up. We're going to use 6 on the Vernier scale. Cool, 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 cool. So we get 775, we get 779. So we get 0.7796. So that's going to be our answer for number 10, 0.7796. Okay. Are there any questions about that? Micrometers, calipers, and the like? Most of this last section here you can read for direct measurements on your own. I'll kind of leave it up to you here. This is the one part I kind of wanted to focus on here for like micrometers and calipers. Calipers not so much, but micrometers, yeah, for sure. The other stuff there, again, not as practical, so that's why I'm not like going super hard. On the test, think I only put like one problem from this section, so that was for micrometers problem. So I'm not gonna be like super hard on you guys for this section. If I go over things kind of lightly like this, then that's usually how I take it as well. It's like, okay, I'm not gonna like be super hard on you because I didn't do anything that was I didn't go over everything in super detail, so it's all good. All right. Okay, very good. So that is the end of section 5.5. All right. Now, I do have a very important announcement for you here, because this is the end of chapter 5. We still will have a class on Friday at 10 o'clock. That's still going to be true. We're going to start with chapter 6, which is the second half of the book. But what I do want to point out here specifically for all of you is that the chapters 1 to 5 test will now be due. Okay, so now you have a chance to go ahead and take the chapters 1 to 5 test at this point. All right. This test here obviously won't be due today. I mean, goodness no. But this test here, well, I'll make it due here by next Friday. So next Friday here is when the test will be due. So the chapter 1 to 5 test is due on the 20th there. So the 20th, which is next Friday, is when that first test will be due. Again, there'll be, let me just make sure here. Wait, what? Okay, never mind. Why were you blaring at me? Anyway, so the first test that will be due there, again, is due next Friday. There is a practice test, okay? There is a practice test on there's a practice test on the on my math lab, of course. That practice test will be exactly the questions that you'll see on the real test, not with the same numbers, of course, but the same exact concepts and whatnot. Now, the test there is 50 questions, okay, for this test. So there's 50 questions for this test. Again, you get a few retries here. You get like a couple retries of which to hopefully improve your score. You don't have kind of weird. Okay. Now I was like stating about important things here. No, your homework will not be late. The homework is all is open until the end of the semester, which is on the 18th, I think, is when I set that date. So, off the top of my head. So I would suggest getting going on that because there's quite a few problems to do. Okay. Now, having said that, let me go ahead and state a few more things. You can practice on the practice test as many times as you want. Again, once you finish the questions, it'll give you the feedback there. On the real test, because there's so many questions there, I don't expect you to finish it necessarily in one sitting. There is a save for later option that has been set. So basically, what that means is that let's say you want to do, a few questions here, a few questions there. You can go ahead and do a few questions. The only thing is that you log out, and then when you log back in again, you just can't redo the same questions that you did from the previous session. So any questions that you took any questions that you did from the previous session, you can't do again. So again, that's part of the save for later option there on my math lab. I've given you plenty of time here. There's a plenty big time limit there. I like to give lots and lots of time. Okay, so I don't remember what I set it at, but it was like 4 hours, 6 hours, something to that effect. All right, so you can take your time through the test there. I can always extend the time if you request to do so. So it doesn't really matter to me. All I really care about is that you take your time. Okay, all I'd like you to do is take your time, go at a pace that you're comfortable with, and then get it done. Get it done. So if you do the practice test there, it will be extremely helpful. You'll have a great preview about what to expect, and then you can go ahead and try the real test once you're good and ready. So and again, there's retries on that test. So um, I think there's like 2 or 3 retries. There's 1, 2, or 3 retries. It'll say on the thing. So I kind of forgot actually. Let me actually check that real fast. Uh, yeah, I always like to give a fair exam. So there's not the kind of guy who'd be like, yeah, you get screwed. Like, nah, that seems rather boring. So let me give me just a second here. Oh, whoops, that's the wrong one. That's not what I want to look at. Hang on a second, guys. I want to check one thing here, and then I want to give you proper stuff. It's rather important for me. Oh, okay. Okay. So yes, I can do that, Bren. So I put it at 8 hours. 8 hours, is 8 hours enough time for you to finish fit that, or do you want me to extend that? I put it at 8 hours. So I don't know. What do you guys think? Wow. Made you mad, man. Thank you for the resub. Holy cow. Wow, that's really super kind of you, dude. Um, Dude, it's really super kind, man. Jeez, I don't know if I deserve it, but I don't know if I deserve it. Made you mad, but I really appreciate your support. It's really kind of you, my friend. Really super kind. I still don't know if I deserve that. um, so 8 hours is enough, and I have three. Yeah, I put 3 retries on there. So I put 3 retries on there. So that should be or 3 tries. So you get 3 tries total. The best of 3 will be your score. Okay. Is it okay for 8 hours? Yeah, I can put whatever time limit I want. So I put a time limit there so it kind of goads you to get it done. But you could take the full 8 hours for the test. It's totally up to you, man. So the time won't go away, by the way, once you the time won't the time won't go if you do the save for later thing. Let's say you log out, the time will stop there and then it'll restart at the time that left once you restart that test again. So yeah, you have to finish it by the 20th. So I should see a score in the grade book by the 20th. That's correct. Okay. So I want to give you plenty of chances here, and I don't want you to feel overwhelmed at the same time. Okay. All right. I hope that'll be okay. You can only open No, 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 no. You're misunderstanding me, Jasmine. No, no, no. That's not what I said. No. That's not what I said there. So what I'm saying is that the test is open right now, okay? And you can practice on it right now, and you could take the test right now. You could do it earlier than the 20th. It's just due by the 20th at 11:59 p.m. Still having connection issues. So I guess it is what it's gonna be. So I increase that buffer a bit. Then after yeah. So take your time. This is not about me, it's about you. So take your time, okay? Any other questions that you guys have? Any more questions about the test or anything else? Yeah, I know. The connection was good for most of the part of the class that mattered, I suppose. Ay ay ay. Ay ay ay. I never win. Well, this connection never wins, but well, at least it did things. Things. All right. Nope. Okay. So that'll take care of it for today, everybody. We're going to come back on Friday, okay? Friday, 10 o'clock, okay? We're going to start Chapter 6, okay? And we're going to get things going with the second half of this book, all right? And that's what's on the agenda, all right? Okay. Thank you very much, everybody, for coming on out here today, all right? And I will see you in a couple of days, okay? Have yourself a great day, everybody, and we will see you later. All right, everybody. Take care of yourselves. Start the test if you like. It's open and available for you right now. Go ahead and get some practice in before you take that real one. All right. Have a great one, everybody.